So I'm working out of the OpenStax Statistics Chapter 7 Excel file. So we're going to work through this example that has to do with the central limit theorem and statistics exam scores. So you can access the OpenStax textbook for free. You can look in the description of the video for a link. And the Excel file that you're about to see here, you can download it totally for free at dividingconquermath.com. Just go to the OpenStax statistics section. So we're working from the first tab in this Excel workbook. So this has been worked out for you just so you can kind of see like a setup here. So the idea here is that we have an unknown distribution that has a mean of 90 and a standard deviation of 15. And then we have sample sizes of n equals 25 are drawn randomly from the population. So two parts to this. We have find the probability that the sample mean is between 85 and 92. And then find the value that is 2 standard deviations above the expected value 90 of the sample mean. Okay, so the thing that I want you to kind of notice here is that there's several things that are kind of important because we're making an important pivot in the class. That's a Friends reference. I've just rewatched all of that. Anyways, so first of all, like notice how this data has been presented to you. So we have an unknown distribution, which in and of itself is kind of saying we know that some population has a mean of 90 and a standard deviation of 15. So most of the time we don't actually know like population data, right? But we're saying for the sake of learning this that we know this information. And then we're talking about from that population, we are taking samples of size n equals 25. Now, if you watch the video where I walked you through the central limit theorem and that kind of exercise of like how we build up to the central limit theorem, you'll remember that we had that huge data set and then we started taking different sample sizes from it. This is kind of what is happening here. So we're talking about sample sizes of 25. So appreciate in the language how this language is different from the previous chapters. So this is saying find the probability that the sample mean is between 85 and 92. So it's not just a data point, it's specifically the mean of this 25-piece data set. What is the probability that that mean is between 85 and 92? So you just want to pay attention to this because this is the big pivot that we're making. And then we have the other question. Okay, so to answer part A, we have to now keep track of what is going on here. So we have some given data. So kind of moving forward now, you're going to have the data that you've been given and then the data that you're actually going to use. So the given data is that we have a mean of 90. We're taking sample sizes of n equals 25. And we have population data, so I can say this time that this is sigma. So this is what was given above. But to talk about a sample mean, what we have to do is we have to move into that sampling distribution of means, and I just have a tendency to abbreviate that distribution of means. So when we move into the sampling distribution of means, so we refer to the mean that we were given. So the sampling distribution of means matches that mean, but our standard deviation is adjusted. So we take the standard deviation from the data that we've been given divided by the square root of whatever our sample sizes are. Okay, so that is kind of our first important pivot because now moving forward, this is going to be the information that we're doing our probability calculations off of. Okay, so now let's move into calculating this particular probability. And maybe it would be helpful if we had a visual. Okay, so here's the situation that we're talking about. And I want to be clear as to what it is that we're looking at. So notice that this axis here, this is not X values. These are not individual data points. These are now means. So this axis, as we kind of move forward now in the class, we might not always label the axis, but when we move into the sampling distribution of means, this axis now is X bar, not X. So there's these like subtle shifts that have happened. And so this is a normal distribution. It is centered at where your distribution of means is centered at. So that would be still 90. And so I want to find this probability that my mean falls between 92 and 85. So here you go. Now I will also just state this just to be clear. So I'm using Excel. So technically this X should be an X bar. So, you know, there are some drawbacks to how we notate things in Excel. But, you know, visually this is what we're doing. We're really trying to find like this sample mean. Technically this should be an X bar, but, you know, please forgive me. Okay, so anyways. So to find this mean then, we're going to take the area to the left of 92 minus the area to the left of 85. So we've done these calculations in the past. So I just want you to appreciate then how do I set up my calculation? That's kind of the whole point of this now. So first I take the area to the left of 92, so I plug in my 92, but notice that I'm referencing my distribution of means. So I'm referencing this mean, and then I'm referencing my sigma, so my standard deviation, also from my sampling distribution of means. So I have this one minus the other one, so I've got the same thing except I just plug in the 85. So now we're shifting our calculations to using these. And I get it. You might be saying to yourself, oh, but if the mean is the same from the given data, why do I have to write this out? You really want to set up in your mind that you've made this pivot between the two, because if you are flipping back and forth between distributions, as we will later in this workbook, this can get super confusing. So having like kind of two separate buckets is going to help your brain hopefully make sense of this. Okay, so the other question here is find the value that is 2 standard deviations above the expected value 90 of the sample mean. So again, notice that key language here, we're talking about a sample mean. So we're staying within these sampling distributions of means. And so here I'm going to take my mean plus 2 standard deviations, so 2 times this number. You can see that that's my calculation here, and that's going to give me this particular value of 96.